let's try. Okay, here we go. This is question 11.9b. We're taking one bromobutane, and we want to make this compound here. And let's face it, in organic chemistry 1, epoxides didn't come up a whole heck of a lot. They'll come up a lot in organic chemistry 2. But what I was trying to say to my students before I started recording here was, how would I make an epoxide? Well, there's only one way that we know how to do that, and that's to start with an alkene. Could anybody tell me what the conditions would be to take an alkene and convert it into an epoxide? It is not a trick question. Yeah, exactly. Thanks, Skylar. It would be something like MCPBA, MCPBA, metachloropurbenzoic acid, or any kind of peroxy acid, right? Like this, a peroxycarboxylic acid. And that's how you make an epoxide. The thing is, we don't see the epoxide a lot in organic chemistry 1, because normally we take that and then we treat it with H3O plus to make a trans diol, but that's neither here nor there for this question. So let's eliminate that. So now we want to go from a compound that has 4 carbons to a compound with 6 carbons. Well, we don't know a whole lot of ways to grow a carbon skeleton, do we? But if we treated this with sodium acetylide, we would do an SN2 reaction like this, and that would give us a molecule that looks something like this, right? We end up with 1 hexyne. And then if we want to convert that into the alkene, well, then we can just do selective reduction. And we could either choose sodium and liquid ammonia, or we could use hydrogen and Lindlar's catalysts. So Lindlar's catalyst like that. And so it's a total of what? We got 1, 2, 3 steps. So not too bad, a 3-step synthesis. So this is 11.9b. Let's try 11.9c. I have a star by this one in my notes. I must think it's a good one. Whenever I put a star by it, it's a question I like. So 11.9c, we started with this geminal dibromide here. And we have a geminal dimethyl here. And we want to convert that into this methyl ketone. Right now, when did we ever see methyl ketones in organic chemistry 1? The only option that we have is we would have to start out with, or we'd have to have this alkyne at some point, and then we would take that and we would do a Markov-Nikov addition of water, wouldn't we? Right? If we do a Markov-Nikov addition of water here, using mercuric sulfate, sulfuric acid, and water, that would produce an enol, which would tautomerize to give us the methyl ketone. Then the question becomes a little simpler. How do we go from the gem dimethyl to the alkyne? And the only way we have to do that is to treat it with excess sodium amide in the first step, and then we put water on it to quench the reaction. That will give us that alkyne that we wanted. That's not a very good looking alkyne, is it? There we go. There's our alkyne. And then all we have to do is to treat this with, you know what, let me draw the enol just for fun. I'll treat it with mercuric sulfate, sulfuric acid, and water. And then we end up with this enol. Let's draw the enol, which is the result of the Markov-Nikov addition of water. So here's our enol. I put it in the square brackets. That means it's non-isolable. That means it's going to rearrange quickly or undergo tautomerization to give us the methyl ketone. Let's try D. Oh man, I have another star by that one. I must think that one's good too. So this is 11.9D. Oh, this is a fun one. We started with 2,3-dimethylbutane and we want to make acetone. Could anybody suggest where I might start with this one? And it's not a trick. You know I wouldn't try to do that. Anybody have an idea where I might start with this one? Keep in mind, I'm starting with an alkane. All right, we don't have a lot of options when we're starting with an alkane. What would I treat this with if I have an alkane? What's the only possibility I've got? Could somebody tell me what the only literal possibility I've got would be? Exactly. I'd have to brominate it. So bromine and light, that would give us this compound, like that. If I treat this with a non-hindered base like sodium methoxide, I end up with this symmetrical alkene, which I could cut in two, couldn't I? Right? If I try that skill builder that we used in Organic Chemistry 1 for the ozonolysis of an alkene, right? In the first step, we treat it with ozone. In the second step, we treat it with DMS. If you remember that skill builder, what you do is you erase the bond, and then you draw oxygens at the end like this, and you can see you end up with 2 molecules of acetone. So you actually end up with 2 molecules of acetone in this case, but that's neither here nor there. You're still taking the starting material and converting it into acetone. All right. We already did E. I just noticed that now. Let's try one more, and then we'll call it a day for chapter 11, and we'll start moving on. It's some new chemistry for you. So this is 11.9 F. We have this geminal dibromide, right? Gemini twins. Both bromines are on the same carbon. And we want to make propionic acid, which is the acid that's responsible for the tangy flavor of Swiss cheese. Right? Well, what do we do? The only thing that we know how to do with a geminal dibromide is to treat it with excess sodium amide followed by water. We do that double E2, and in that case, we'd end up with this molecule, which is 1-butyne. Then if we take this and we treat it with ozone followed by water, not only do we cut this bond, right, we end up with acetic acid, but we also end up with CO2, carbon dioxide. And so those are some good practice problems from chapter 11.